So hello everybody and welcome back to another episode of 100 Days of Code with me, Lily Code. Today we are on day 45 and I have my Bumblebee jumper on, ready to go. No, I'm just joking. But today I'm going to take a slight detour from what we've been previously doing, which was we were following a React tutorial and I actually want to learn Kubernetes now. So I'm going to take a detour from the React course, which this is the beauty of 100 Days of Code. You can do whatever you want for the 100 days. And today I'm going to do Kubernetes. So I've been recommended, this is the official documentation, which is always a good place to start, you know. So I might just have a read of the official documentation with you guys beside me, here with me. And then I also found this online course, Kubernetes tutorial full course in 4 hours on YouTube, so we could look at that. And then this is actually the recommended course that I've been recommended in work. So this goes through what Kubernetes is, the architecture, containers and workloads, basic security controls, and deploying your first app. So really, I would love to do this one. I have been recommended it. I will include the link to this in the description box below. Let me just make a note of that because I can forget the links if I don't write it down. I'm looking at a computer here, so no need to be scurrying around for a pen. I'll just pause it for a moment and write this down. Okay guys, so I took note of that course and I'll include it in the description box down below. And what I've actually decided to do from reflecting is to do the YouTube tutorial style. So I will include the YouTube tutorial. I'll include the other link from Lightspin. But just with this particular one, you needed to log in, you needed to set up an account and log in order to see this. So maybe not everybody can access this, and then also perhaps it's not publicly available. Whereas this particular course, it's on the net, someone has put it on YouTube, so I'm taking that to mean it's a free for all, so we can do this one together. So anyway, let's get started. Let's find out about Kubernetes. I'm going to literally watch this video. This is what I'm going to do for today, so let's watch it together.
Welcome to this complete Kubernetes course. The course is theoretic explanations, but also hands-on demos.
A lady, woo! We got another, Nana. Thanks, Nana. We got another lady in tech. There's not many of us, but we're rising to the surface.
For you to follow along. So Let's quickly go through the topics I'll cover in this course. The first part gives you a great introduction to Kubernetes. We'll start with the basic concepts of what Kubernetes actually is, what problems it solves, and the Kubernetes architecture. You will learn how you can use Kubernetes by showcasing.
Rather than picking this up from the microphone, I'll actually just do it from the computer itself. No, that won't work actually. Oh, because then when I talk, my microphone will be muted. It's one or the other. So let's continue. No more distractions. Okay.
All the main components. After learning the main concepts, we will learn and install MiniCube for a local Kubernetes cluster, and we will go through the main commands of creating, debugging, and deleting pods using kubectl, which is Kubernetes command line tool. After knowing kubectl main commands, I will explain Kubernetes YAML configuration files, which we will use to create and configure components.
Cool.
You will learn how you can use Kubernetes by showcasing all the main components. After learning the main concepts, we will learn and install MiniCube for a local Kubernetes cluster, and we will go through the main commands of creating, debugging, and deleting pods using kubectl, which is Kubernetes command line tool. After knowing kubectl main commands, I will explain Kubernetes YAML configuration files, which we will use to create and configure components. Then we will go through a practical use case where we'll deploy a simple application setup in Kubernetes cluster locally to get your first hands-on experience with Kubernetes and feel more confident about the tool. In the second part, we will go into more advanced and important concepts like organizing your components using namespaces, how to make your app available from outside using Kubernetes Ingress, and learn about Helm, which is the package manager for Kubernetes. In addition, we will look at 3 components in more detail. First, how to persist data in Kubernetes using volumes. Second, how to deploy stateful applications like databases using stateful set component. And lastly, we will look at the different Kubernetes service types for different use cases. If you like the course, be sure to subscribe to my channel for more videos like this, and also check out the video description for more related courses on Udemy, etc. If you guys have any questions during the course or after the course, or you want to simply stay in touch, I would love to connect with you on social media, so be sure to follow me there as well.
I will. Very nice, actually. That was a very nice introduction, I have to say, and I just really quite enjoyed that. Okay, so I subscribed. Good. So, yeah, great introduction from her. It seems like we're going to cover a lot, so I'm excited. Let's get going. I won't hang around. Great. Very nicely done, the whole course. Very nice. Good world.
So in this video,
Good
I'm going to explain
woman.
what Kubernetes is.
I meant to say
we're going to
good
start
woman.
off with the definition to see what official definition is and what it does. Then we're going to look at the problem solution case study of Kubernetes. Basically, why did Kubernetes even come around and what problems does it solve? So let's jump in right into the definition. What is Kubernetes? So Kubernetes is an open source container orchestration framework, which was originally developed by Google. So on the foundation, it manages containers, be it Docker containers or from some other technology. Which basically means that Kubernetes helps you manage applications that are made up of hundreds or maybe thousands of containers, and it helps you manage them in different environments, like physical machines, virtual machines, or cloud environments, or even hybrid deployment environments. So what problems does Kubernetes solve, and what are the tasks of a container orchestration tool actually? So to go through this chronologically, the rise of microservices caused an increased usage of container technologies, because the containers actually offer the perfect host for small, independent applications like microservices. And the rise of containers and the microservice technology actually resulted in applications that they're now comprised of hundreds or sometimes maybe even thousands of containers. Now, managing those loads of containers across multiple environments using scripts and self-made tools can be really complex and sometimes even impossible. So that specific scenario actually caused the need for having container orchestration technologies. So what those orchestration tools like Kubernetes do is actually guarantee following features. One is high availability. In simple words, high availability means that the application has no downtime, so it's always accessible by the users. A second one is scalability, which means that application has a high performance. It loads fast and users have a very high response rate from the application. And the third one is disaster recovery, which basically means that if an infrastructure has some problems, like data is lost or the servers explode or something bad happens with the service center, the infrastructure has to have some kind of mechanism to pick up the data and to restore it to the latest state, so that application doesn't actually lose any data. And the containerized application can run from the latest state after the recovery. And all of these are functionalities that container orchestration technologies like Kubernetes offer. So in this video, I want to give you an overview of the most basic fundamental components of Kubernetes, but just enough to actually get you started using Kubernetes in practice, either as a DevOps engineer or a software developer. Now, Kubernetes has tons of components, but most of the time you're going to be working with just a handful of them. So I'm going to build a case of a simple JavaScript application with a simple database, and I'm going to show you step by step how each component of Kubernetes actually helps you to deploy your application and what is the role of each of those components.
Cool.
So let's start with the basic setup of a worker node, or in Kubernetes terms, a node, which is a simple server, a physical or virtual machine, and the basic component or the smallest unit of Kubernetes is a pod. So what pod is basically an abstraction over a container. So if you're familiar with Docker containers or container images, so basically what pod does is it creates this running environment or a layer on top of the container. And the reason is because Kubernetes wants to abstract away the container runtime or container technologies so that you can replace them if you want to, and also because you don't have to directly work with Docker or whatever container technology you use in a Kubernetes. So you only interact with the Kubernetes layer. So we have an application, pod, which is our own application, and that will maybe use a database, pod, with its own container. And this is also an important concept here. Pod is usually meant to run one application container inside of it. You can run multiple containers inside one pod, but usually it's only the case if you have one main application container and a helper container or some side service that has to run inside of that pod. And as you see, this is nothing special. You just have one server and two containers running on it with an abstraction layer on top of it. So now let's see how they communicate with each other in Kubernetes world. So Kubernetes offers out of the box a virtual network, which means that each pod gets its own IP address, not the container. The pod gets the IP address, and each pod can communicate with each other using that IP address, which is an internal IP address. Obviously, it's not the public one. So my application container can communicate with database using the IP address. However, pod components in Kubernetes, also an important concept, are ephemeral, which means that they can die very easily. And when that happens, for example, if I lose a database container because the container crashed because the application crashed inside, or because the node, the server that I'm running them on, ran out of resources, the pod will die and a new one will get created in its place. And when that happens, it will get assigned a new IP address, which obviously is inconvenient if you are communicating with the database using the IP address, because now you have to adjust it every time pod restarts. And because of that, another component of Kubernetes called service is used.
Okay.
So service is basically a static IP address or permanent IP address that can be attached, so to say, to each pod. So my app will have its own service and database pod will have its own service. And the good thing here is that the life cycles of service and the pod are not connected. So even if the pod dies, the service and its IP address will stay. So you don't have to change that endpoint anymore. So now obviously you would want your application to be accessible through a browser, right? And for this you would have to create an external service. So external service is a service that opens the communication from external sources. But obviously you wouldn't want your database to be open to the public requests, and for that you would create something called an internal service. So this is a type of a service that you specify when creating one. However, if you notice, the URL of the external service is not very practical. So basically what you have is an HTTP protocol with a node IP address, so of the node, not the service, and the port number of the service, which is good for test purposes if you want to test something very fast, but not for the end product. So usually you would want your URL to look like this if you want to talk to your application with a secure protocol and a domain name. And for that, there is another component of Kubernetes called ingress. So instead of service, the request goes first to ingress and it does the forwarding then to the service. So now we saw some of the very basic components of Kubernetes. And as you see, this is a very simple setup. We just have one server and a couple of containers running and some services. Nothing really special, where Kubernetes HTTP protocol with a node IP address, so you don't.
So I get everything there. I understand everything. I just don't get the ingress part. Maybe because I was making notes and I started to get feeling a bit uncomfortable. Anyway, just rewinding, gonna watch the ingress part once again, try and pick it up, and if I'm not sure what's happening, move on, because we're going to build this. So
have to change that endpoint anymore. So now obviously you would want your application to be accessible through a browser, right? And for this you would have to create an external service. So external service is a service that opens the communication from external sources. But obviously you wouldn't want your database to be open to the public requests, and for that you would create something called an internal service. So this is a type of a service that you specify when creating one. However, if you notice, the URL of the external service is not very practical. So basically what you have is an HTTP protocol with a node IP address, so of the node, not the service, and the port number of the service, which is good for test purposes if you want to test something very fast, but not for the end product. So usually you would want your URL to look like this if you want to talk to your application with a secure protocol and a domain name. And for that, there is another component of Kubernetes called ingress. So instead of service, the request goes first to ingress and it does the forwarding then to the service. So now we saw some of the very basic components of Kubernetes. And as you see, this is a very simple setup. We just have one server and a couple of containers running and some services. Nothing really special where Kubernetes advantages or the actual cool features really come forward, but we're going to get there step by step. So let's continue.
Cool.
So as we said, pods communicate with each other using a service. So my application will have a database endpoint, let's say called MongoDB service, that it uses to communicate with the database. But where do you configure usually this database URL or endpoint? Usually you would do it in application properties file or as some kind of external environmental variable, but usually it's inside of the built image of the application. So for example, if the endpoint of the service or service name in this case changed to MongoDB, you would have to adjust that URL in the application. So usually you'd have to rebuild the application with a new version and you have to push it to the repository, and now you'll have to pull that new image in your pod and restart the whole thing. So a little bit tedious for a small change like database URL. So for that purpose, Kubernetes has a component called config map. So what it does is it's basically your external configuration to your application. So config map would usually contain configuration data like URLs of a database or some other services that you use. And in Kubernetes, you just connect it to the pod so that pod actually gets the data that config map contains. And now if you change the name of the service, the endpoint of the service, you just adjust the config map and that's it. You don't have to build a new image, you don't have to go through this whole cycle. Now part of the external configuration can also be database username and password, right? Which may also change in the application deployment process. But putting a password or other credentials in a config map in a plain text format would be insecure, even though it's an external configuration. So for this purpose, Kubernetes has another component called secret. So secret is just like config map, but the difference is that it's used to store secret data, credentials for example, and it's stored not in a plain text format, of course, but in base 64 encoded format. So secret would contain things like credentials. And of course, database user, you could also put in config map, but what's important is the passwords, certificates, things that you don't want other people to have access to would go in the secret. And just like config map, you just connect it to your pod so that pod can actually see those data and read from the secret. You can actually use the data from config map or secret inside of your application pod using, for example, environmental variables, or even as a properties file. So now to review, we've actually looked at almost all mostly used Kubernetes basic components. We've looked at the pod, we've seen how services are used, what is ingress component useful for, and we've also seen external configuration using config map and secrets. So now let's see another very important concept generally, which is data storage and how it works in Kubernetes. So we have this database pod that our application uses, and it has some data, or it generates some data. With this setup that you see now, if the database container or the pod gets restarted, the data would be gone. And that's problematic and inconvenient, obviously, because you want your database data or log data to be persisted reliably long term. And the way you can do it in Kubernetes is using another component of Kubernetes called volumes. And how it works is that it basically attaches a physical storage on a hard drive to your pod. And that storage could be either on a local machine, meaning on the same server node where the pod is running, or it could be on a remote storage, meaning outside of the Kubernetes cluster. It could be a cloud storage, or it could be your own premise storage, which is not part of the Kubernetes cluster. So you just have an external reference on it. So now when the database pod or container gets restarted, all the data will be there, persisted. It's important to understand the distinction between the Kubernetes cluster and all of its components and the storage. Regardless of whether it's a local or remote storage, think of a storage as an external hard drive plugged into the Kubernetes cluster. Because the point is, Kubernetes cluster explicitly doesn't manage any data persistence, which means that you as a Kubernetes user or an administrator are responsible for backing up the data, replicating and managing it, and making sure that it's kept on a proper hardware, etc. Because it's not taking care of Kubernetes. So now let's see everything is running perfectly and a user can access our application through a browser. Now with this setup, what happens if my application pod dies, right? Crashes, or I have to restart the pod because I built a new container image, basically I would have a downtime where a user can reach my application, which is obviously a very bad thing if it happens in production. And this is exactly the advantage of distributed systems and containers. So instead of relying on just one application pod and one database pod, etc., we are replicating everything on multiple servers. So we would have another node where a replica or clone of our application would run, which will also be connected to the service. So remember previously we said the service is like a persistent static IP address with a DNS name, so that you don't have to constantly adjust the endpoint when a pod dies. The service is also a load balancer, which means that the service will actually catch the request and forward it to whichever pod is least busy. So it has both of these functionalities. But in order to create this second replica of the My Application pod, you wouldn't create a second pod, but instead you would define a blueprint for a My Application pod and specify how many replicas of that pod you would like to run. And that component or that blueprint is called deployment, which is another component of Kubernetes. And in practice, you would not be working with pods, or you would not be creating pods. You would be creating deployments, because there you can specify how many replicas, and you can also scale up or scale down the number of replicas of pods that you need. So with pod, we said that pod is a layer of abstraction on top of containers, and deployment is another abstraction on top of pods, which makes it more convenient to interact with the pods, replicate them, and do some other configuration. So in practice, you would mostly work with deployments and not with pods. So now if one of the replicas of your application pod would die, the service will forward the request to another one. So your application would still be accessible for the user. So now you're probably wondering, what about the database pod? Because if the database pod died, your application also wouldn't be accessible. So we need a database replica as well. However, we can't replicate database using a deployment. And the reason for that is because database has a state, which is its data. Meaning that if we have clones or replicas of the database, they would all need to access the same shared data storage. And there you would need some kind of mechanism that manages which pods are currently writing to that storage or which pods are reading from that storage in order to avoid data inconsistencies. And that mechanism, in addition to replicating feature, is offered by another Kubernetes component called stateful set. So this component is meant specifically for applications like databases. So MySQL, MongoDB, Elasticsearch, or any other stateful applications or databases should be created using stateful sets and not deployments. It's a very important distinction. And stateful set, just like deployment, would take care of replicating the pods and scaling them up or scaling them down, but making sure the database reads and writes are synchronized so that no database inconsistencies are offered. However, I must mention here that deploying database applications using stateful set in Kubernetes cluster can be somewhat tedious. So it's definitely more difficult than working with deployments where you don't have all these challenges. That's why it's also a common practice to host database applications outside of the Kubernetes cluster and just have the deployments or stateless applications that replicate and scale with no problem inside of the Kubernetes cluster and communicate with the external database. So now that we have two replicas of my application pod and two replicas of the database, and they're both load balanced, our setup is more robust, which means that now even if node 1, the whole node server, was actually rebooted or crashed and nothing could run on it, we would still have a second node with application and database pods running on it, and the application would still be accessible by the user until these two replicas get recreated, so you can avoid downtime. So to summarize, we have looked at the most used Kubernetes components. We start with the pods and the services in order to communicate between the pods, and the ingress component, which is used to route traffic into the cluster. We've also looked at external configuration using config maps and secrets, and data persistence using volumes. And finally, we've looked at pod blueprints with replicating mechanisms like deployments and stateful sets, where stateful set is used specifically for stateful applications like databases. And yes, there are a lot more components that Kubernetes offers, but these are really the core, the basic ones. Just using these core components, you can actually build pretty powerful Kubernetes clusters.
Very good. Very well explained.
In this video, we're going to talk about basic architecture of Kubernetes. So we're going to look at two types of nodes that Kubernetes operates on. One is master and another one is slave, and we're going to see what is the difference between those and which role each one of them has inside of that cluster. And we're going to go through the basic concepts of how Kubernetes does what it does and how the cluster is self-managed and self-healing and automated, and how you as an operator of the Kubernetes cluster should end up having much less manual effort. And we're going to start with this basic setup of one node with two application pods running on it. So one of the main components of Kubernetes architecture are its worker servers or nodes. And each node will have multiple application pods with containers running on that node. And the way Kubernetes does it is using 3 processes that must be installed on every node that are used to schedule and manage those pods. So nodes are the cluster servers that actually do the work. That's why sometimes also called worker nodes. So the first process that needs to run on every node is the container runtime. In my example, I have Docker, but it could be some other technology as well. So because application pods have containers running inside, a container runtime needs to be installed on every node. But the process that actually schedules those pods and the containers then underneath is kubelet, which is a process of Kubernetes itself, unlike container runtime, that has interface with both container runtime and the machine, the node itself. Because at the end of the day, kubelet is responsible for taking that configuration and actually running a pod or starting a pod with a container inside, and then assigning resources from that node to that container, like CPU, RAM, and storage resources. So usually Kubernetes cluster is made up of multiple nodes, which also must have container runtime and kubelet services installed. And you can have hundreds of those worker nodes, which will run other pods and containers and replicas of the existing pods, like my app and database pods in this example. And the way that communication between them works is using services, which is sort of a load balancer that basically catches the request directed to the pod or the application, like database for example, and then forwards it to the respective pod. And the third process that is responsible for forwarding requests from services to pods is actually kubeproxy, that also must be installed on every node. And kubeproxy has actually intelligent forwarding logic inside that makes sure that the communication also works in a performant way with low overhead. For example, if an application, my app replica, is making a request to the database, instead of service just randomly forwarding the request to any replica, it will actually forward it to the replica that is running on the same node as the pod that initiated the request. Thus, this way avoiding the network overhead of sending the request to another machine. So to summarize, 2 Kubernetes processes, kubelet and kubeproxy, must be installed on every Kubernetes worker node, along with an independent container runtime, in order for Kubernetes cluster to function properly. But now the question is, how do you interact with this cluster? Or do you decide on which node a new application pod or database pod should be scheduled? Or if a replica pod dies, what process actually monitors it and then reschedules it or restarts it again? Or when we add another server, how does it join the cluster to become another node and get pods and other components created on it? And the answer is, all these managing processes are done by master nodes. So master servers or master nodes have completely different processes running inside. And these are 4 processes that run on every master node that control the cluster state and the worker nodes as well. So the first service is API server. So when you as a user want to deploy a new application in a Kubernetes cluster, you interact with the API server using some client. It could be a UI like Kubernetes dashboard, could be a command line tool like kubelet, or a Kubernetes API. So API server is like a cluster gateway, which gets the initial requests of any updates into the cluster or even the queries from the cluster. And it also acts as a gatekeeper for authentication to make sure that only authenticated and authorized requests get through to the cluster. That means whenever you want to schedule new pods, deploy new applications, create a new service or any other components, you have to talk to the API server on the master node, and the API server then validate your request, and if everything is fine, then it will forward your request to other processes in order to schedule the pod or create this component that you requested. And also, if you want to query the status of your deployment or the cluster health, etc., you make a request to the API server, and it gives you the response, which is good for security because you just have one entry point into the cluster. Another master process is a scheduler. So as I mentioned, if you send an API server a request to schedule a new pod, API server, after it validates your request, will actually hand it over to the scheduler in order to start the application pod on one of the worker nodes. And of course, instead of just randomly assigning it to any node, scheduler has this whole intelligent way of deciding on which specific worker node the next pod will be scheduled, or next component will be scheduled. So first it will look at your request and see how much resources the application that you want to schedule will need, how much CPU, how much RAM, and then it's going to look at, and it's going to go through the worker nodes and see the available resources on each one of them. And if it sees that one node is the least busy or has the most resources available, it will schedule the new pod on that node. An important point here is that scheduler just decides on which node a new pod will be scheduled. The process that actually does the scheduling, that actually starts that pod with a container, is the kubelet. So it gets the request from the scheduler and executes that request on that node. The next component is controller manager, which is another crucial component, because what happens when pods die on any node, there must be a way to detect that the nodes died and then reschedule those pods as soon as possible. So what controller manager does is detect state changes like crashing of pods, for example. So when pods die, controller manager detects that and tries to recover the cluster state as soon as possible. And for that, it makes a request to the scheduler to reschedule those dead pods. And the same cycle happens here, where the scheduler decides, based on the resource calculation, which worker nodes should restart those pods again, and makes requests to the corresponding kubelets on those worker nodes to actually restart the pods. And finally, the last master process is etcd, which is a key value store of a cluster state. You can think of it as a cluster brain, actually, which means that every change in the cluster, for example, when a new pod gets scheduled, when a pod dies, all of these changes get saved or updated into this key value store of etcd. And the reason why etcd store is a cluster brain is because all of this mechanism with scheduler, controller manager, etc. works because of its data. So for example, how does scheduler know what resources are available on each worker node?
Okay guys, so I just had to take a quick break there, like my brain was starting to switch off on me. So I took a quick break, and now I'm just going to show you something that I do in order to help me refocus if my brain is feeling tired. They're called yogic brain squats, and I just thought if I was tired, maybe you guys were tired too. So the way they work is you cross one arm over one ear and you hold your earlobe. And this is shown to realign your brain, to realign the hemispheres of your brain, to help with concentration and focus. They've done studies in schools. You can look it up. It's been on the news in the past. So this is very useful. So you cross one arm over and hold your opposite earlobe, and you do the same with the other hand. And then you just go up and down for 15 times and do a squat. So breathe on the way down. Go as low as you can, and then exhale on the way up. And you can do 15 reps of that. Maybe nobody is feeling tired whatsoever. Maybe you're all awake and feeling dandy, but I know my concentration was starting to lack, so I just paused it for a moment, and let's get back into studying now. So it's okay to take a break, do you know what I mean? We're not robots, we're humans, and it's better to refocus. So I'll show you some other little exercises I do during my working day that are very helpful, but that's one I do, and it does help even just move. I even just stick my head out the window, so that also helps. Just stick your head out the window. So we'll keep watching.
For example, pods died, or that kubelet restarted new pods upon the request of a scheduler, or when you make a query request to API server about the cluster health, or for example your application deployment state, where does API server get all this state information from? So all of this information is stored in etcd cluster. What is not stored in the etcd key value store is the actual application data. For example, if you have a database application running inside of the cluster, the data will be stored somewhere else, not in the etcd. This is just the cluster state information, which is used for master processes to communicate with the work processes and vice versa. So now you probably already see that master processes are absolutely crucial for the cluster operation, especially the etcd store, which contains some data, must be reliably stored or replicated. So in practice, Kubernetes cluster is usually made up of multiple masters, where each master node runs its master processes, where of course the API server is load balanced, and the etcd store forms a distributed storage across all the master nodes. So now that we saw what processes run on worker nodes and master nodes, let's actually have a look at a realistic example of a cluster setup. So in a very small cluster, you would probably have 2 master nodes and 3 worker nodes. Also to note here, the hardware resources of master and node servers actually differ. The master processes are more important, but they actually have less load of work, so they need less resources like CPU, RAM, and storage. Whereas the worker nodes do the actual job of running those pods with containers inside, therefore they need more resources. And as your application complexity and its demand of resources increases, you may actually add more master and node servers to your cluster, and thus forming a more powerful and robust cluster to meet your application resource requirements. So in an existing Kubernetes cluster, you can actually add new master or node servers pretty easily. So if you want to add a master server, you just get a new bare server, you install all the master processes on it, and add it to the Kubernetes cluster. Same way, if you need 2 worker nodes, you get bare servers, you install all the worker node processes, like container runtime, kubelet, and kubeproxy on it, and add it to the Kubernetes cluster. That's it. And this way, you can infinitely increase the power and resources of your Kubernetes cluster as your application complexity and its resource demand increases. So in this video, I'm going to show you what MiniCube and kubectl are and how to set them up. So first of all, let's see what is MiniCube. Usually in the Kubernetes world, when you're setting up a production cluster, it will look something like this. So you would have multiple masters, at least 2 in a production setting, and you would have multiple worker nodes. And master nodes and worker nodes have their own separate responsibility. So as you see on the diagram, you would have actual separate virtual or physical machines that each represent a node. Now, if you want to test something on your local environment, or if you want to try something out very quickly, for example, deploying new application or new components, and you want to test it on your local machine, obviously setting up a cluster like this will be pretty difficult, or maybe even impossible if you don't have enough resources, like memory and CPU, etc. And exactly for that use case, there's this open source tool that is called a MiniCube. So what a MiniCube is basically one node cluster where the master processes and the worker processes both run on one node. And this node will have a Docker container runtime pre-installed. So you will be able to run the containers or the pods with containers on this node. And the way it's going to run on your laptop is through a virtual box or some other hypervisor. So basically, MiniCube will create a virtual box on your laptop, and the node that you see here, this node, will run in that virtual box. So to summarize, MiniCube is a one-node Kubernetes cluster that runs in a virtual box on your laptop, which you can use for testing Kubernetes on your local setup. So now that you've set up a cluster, or a mini cluster on your laptop or PC on your local machine, you need some way to interact with the cluster. So you want to create components, configure it, etc. And that's where kubectl comes in the picture. So now that you have this virtual node on your local machine that represents MiniCube, you need some way to interact with that cluster. So you need a way to create pods and other Kubernetes components on the node. And the way to do it is using kubectl, which is a command line tool for Kubernetes cluster. So let's see how it actually works. Remember we said that MiniCube runs both master and worker processes. So one of the master processes, called API server, is actually the main entry point into the Kubernetes cluster. So if you want to do anything in the Kubernetes, if you want to configure anything, create any component, you first have to talk to the API server. And the way to talk to the API server is through different clients. So you can have a UI, like a dashboard. You can talk to it using Kubernetes API, or a command line tool, which is kubectl. And kubectl is actually the most powerful of all the 3 clients, because with kubectl you can basically do anything in Kubernetes that you want. And throughout this video tutorials, we're going to be using kubectl mostly. So once the kubectl submits commands to the API server to create components, delete components, etc., the worker processes on MiniCube node will actually make it happen. So they will be actually executing the commands to create the pods, to destroy the pods, to create services, etc. So this is the MiniCube setup, and this is how kubectl is used to interact with the cluster. An important thing to note here is that kubectl isn't just for MiniCube cluster. If you have a cloud cluster or a hybrid cluster, whatever, kubectl is the tool to use to interact with any type of Kubernetes cluster setup. So that's important to note here. So now that we know what MiniCube and kubectl are, let's actually install them to see them in practice. I'm using Mac, so the installation process will probably be easier, but I'm going to put the links to the installation guides in the description so you can actually follow them to install it on your operating system.
Okay.
Just one thing to note here is that MiniCube needs a virtualization, because as we mentioned, it's going to run in a virtual box setup or some hypervisor, So you will need to install some type of hypervisor. It could be VirtualBox. I'm going to install a Hyperkit, but it's going to be in those step-by-step instructions as well.
Okay.
So I'm going to show you how to install it on a Mac.
Cool. Okay, cool. So I just better go to the instructions because I'm actually on a Windows. So we will need to take another look at that. So if we come down here to the description, show more. What do we have here? Install MiniCube and install cubectl. Okay. And what else? Okay, so this is literally the beginning. So we've gone through, fair play to this woman. What's her name? Nana. What a great job, Nana. Like, very well laid out course. Really, really, I can learn a lot from you, and fantastic job. Good for you. You are very, very good at this. Anyway, let's stop praising. Well, no, continue to praise. Not just like because we need to get on with things, but fantastic job. Let's continue to watch the video. So I'm going to move YouTube over here so I can check this out, and then I'll just get these things installed.
MiniCube on this macOS version, and I'm going to be using brew to install it. So we will update. And the first thing is that I'm going to install a Hypervisor Hyperkit. So I'm going to go with the Hyperkit.
Okay.
Go ahead and install it. I already had it installed, so with you, if you're doing it for the first time, it might take longer because it has to download all these dependencies and stuff.
Okay, so let's just search in here for Hyperkit and see at what stage she's getting these instructions. Here we go. Okay, so container or virtual machines such as Docker or Hyperkit. Okay, so maybe I should open that in a new tab, but I'll also copy and paste this here. Okay, no, and then let's see. Hyperkit is an open source hypervisor for Mac OS. Hypervisor. Oh, for Mac OS. Right. So what if I don't got a Mac then? What am I supposed to do? Use one of the other ones, obviously. Alright, Docker. I quite like Docker. That'll do. Right, so we'll go with Docker instead. Driver allows you to install Kubernetes into an existing Docker install. On Linux, this doesn't require virtualization to be enabled. Why is nobody telling me about Windows, eh? So, let's just open all of these and see. Podman sounds cool. VMware, that's definitely Windows to my brain. Yeah. Yep. Okay. VMware might be a good one, or else VirtualBox, because I've heard of these. So, you know, get a bit of an experience with the things that I've heard of, you know, which may not be the best approach. I probably haven't heard much about these for a while. So there's too many prerequisites here. Just being lazy, but there is. So we'll continue on. That's taking too long to load. You're out. Podman. Alternative to Docker. I should really use Docker because that's what we use in work, but like I just don't really know what's going on, you know? Like I just am unsure. All I want is a container. So I should just install Docker then, I think. That's the best. We do use Docker in work. So just install Docker, start a cluster. Okay. Okay, so let's try this. Docker is what I use in work. It's what I've used in a previous job. So I should have some experience, but I mean, I'm not going to say, I didn't rush to use it there. Well, just because the initial information I seen didn't seem correct. So here we can see Docker Desktop for Windows. This is a verified publisher, so this is all good. This is like Docker Hub. This is where you can get a lot of information. You can get stuff on Docker here, I'm sure. You can't get nothing. No money messing. I'm not sure what you can get, but I have used this site before a long time ago, so I'm sure. So anyway, we will just go ahead and get Docker for the desktop. So we click that button, get Docker for the desktop. I will go to Documents, sure, why not? Downloads, let's stick it in downloads. Let's go to Documents because, just better. And then from Documents, I will click on this now in a moment. It will say it will open, and then we can go ahead and follow the rest of the instructions. Okay, yeah. So let's have a quick read of these while this is opening. So Hyper-V is a native hypervisor. What even is a hypervisor? Like, that seems like the first time I've heard that word. Is it just a container? What is a hypervisor? Okay, yeah. So a hypervisor, okay, so it sort of is just a container then, I think. Next gen virtualization for dummies, eh? Now I know what's going on. No, I won't say I'm a dummy. I'm not a dummy. We're all learning. So what is a hypervisor? A hypervisor, also known as a virtual machine monitor or a VMM, is software that creates and runs virtual machines. Software that creates and runs virtual machines. Okay, so it's not the virtual machine itself. A hypervisor creates and runs virtual machines. It allows one host computer to support multiple guest VMs by virtually sharing its resources such as memory and processing. Okay, cool. That's enough information for me. Now I know a bit more about what that word means, so I'll just close this window. Here we go. So our Docker installer is getting fired up here. So we will let that happen. I'm just waiting to see where it's going to be. Here we go. Cool. Yeah, just do all of that. That's fine. So it just said add to desktop and something else I can't remember. Sometimes I like to sing when I yawn as well. Singing is just, every opportunity. Oh, it's true though. So, okay, that's just installing there. Let's have a look at this. So, code with Lilly code. Yeah. There you go. Any opportunity, guys. Any opportunity. We can get rid of all of that. And there we go. So we're just waiting for this to unpack so we can install it. This could take a long time, actually, in all honesty. But do you know what? I quite enjoyed that YouTube. I haven't liked her video. I just liked it because great job. I'll actually just put a little comment on. Might seem like strange, well, we're waiting for this to download anyway, but realistically, like, she put in all this time, so brilliant. Thank you. Learning a lot and not started the actual setup yet, which is true. She explained it very clearly, So a lot are two separate words, and then I'll give her a little heart. So, because, share the love. So yeah, that's like about all we can do. We're just waiting for this. This is probably going to take quite some time, I imagine. Anything else we can do? We can read back over some of our documentation. So, cubacell. Install tools. Cubacell. I mean, that's not how you spell anything. Well, it is how you spell whatever that says. Cubacell. I thought she called it cubacell, but cubacell. Who cares? Hey, the good people care. They want to know what to call it. So, Kubernetes command line tool, cubacell, cubacell allows you to run commands against Kubernetes clusters. You can use cubacell to deploy applications, inspect and manage cluster resources, and view logs. For more information, including a complete list of cubacell operations, see the cubacell reference documentation. Oh, cubacell. Oh, let's change to another page. Well, because you're probably not learning anything with me just laughing my head off here because I can't say the word. So, yes, let's continue with the actual documentation. Click on the buttons that describes your target platforms. For other architectures, see the release page. So we have a Windows. I am 68. Where's the other one? 34. 32. And now there's an 86. I didn't know that. Am I thinking of the wrong thing here? Is this like how many bits your computer has? Anyway, release type stable or beta. Well, there's only one option anyway, so, that actually, architecture, doesn't matter. We can't go wrong by leaving that selected, and if we could go wrong, I would go and do some more research, but we'll move on. So the release type stable or beta. Stable just means that, it's the stable current version, whereas the beta is the one that's currently going through testing. They might have new features, new improvements, but it's not fully released yet. It's still in a testing phase. But still, it probably, something big like this MiniCube, I imagine that a beta version there's so much internal testing before it even gets to beta. And yeah, there might be some errors, but there might be some really cool new features. So that's just sort of how that works. You might want to see what the new beta version includes, and if it's something that you would love to have a go at, well then you can decide to install the beta. The installer type .exe download, yep, that's fine. Windows Package Manager would also be handy. Yeah, that's handy. And Chocolatey also will be handy. They're both more handy. Yeah. So let's go with Windows Package Manager. Wingnet? Is that what Windows Package Manager is? Oh, Chocolatey, it must be. Chocolatey is just Choco, yeah. So I might just install Chocolatey, and I should even have it installed already. I just don't know if I have it installed globally, but I should have it installed somewhere, and have a look and then try and just start up our cluster following that. So cool, we'll have a go at continuing this tomorrow, guys, because I'm still just waiting for this. Ooh, it succeeded. Okay, well, it succeeded, but I also have to go for a walk with my friend very, very, very shortly. So yeah, I think now is a good place to leave it because I'm going on a walk and I have to restart Windows. So there you go. Grand, the universe conspired in my favour. So perfecto selecto, guys. Thanks so much for joining me, and have an absolutely wonderful day, and I will see you all tomorrow, and love and peace. Have a lovely day. Enjoy your studying, your coding, and I hope that this was valuable for you. And yeah, I'll leave the link to that lady because realistically we just looked at her video and she was very valuable for me, so I'll include that link for you guys so you can also have a look at her fantastic resources if you're interested in learning Kubernetes. And at the end of all of this, I might do a review of her course or something, so you don't need to sit here and watch it all with me. I'll just give you an overview of the highlights or something. So sounds like a good plan. I hope you all have an absolutely wonderful day. Have a good time. Bye bye, guys. Adios.